Hello everyone, welcome to Grade Up. My name is Hemant Parihar. In previous lecture we have seen the subnetting, and today we will see the more example on subnetting. We will see supernetting and classless IP addressing. In previous lecture we also learned about the classful IP addressing, where we see the class A, class B, class C and all. Today we will learn about classless, which is we are using today nowadays. We are not using the classful, we are using classless. So let's start. So we learn about the subnetting, and we see that why we want to divide a network into subnetwork, and we have also solved an example where we wanted to divide our subnetwork into two networks. Now I give you an IP address, this is an IP address, and now you need to divide it into 4 subnetwork. Okay, so try to do it yourself, and I am also doing with you. So before that, can you tell me to which IP address it is belong? This IP address, to which network it is belong? So if you see that it is belonging, if you see class C is from 192 to 223. So it is belong to class D, and in class D it is like 239. So it's belong to class D, but I should not take the class D, because class D I told you that class D is used for group mailing. So make it as 1. Here we have 1. Okay, now it belong to class C, and now we want it to divide into 4 subnetwork. Okay, so in class C I made it this as 1. Okay, this is 1. Now in class C what's happened, that's how many bit are used for network ID and host ID? 24 bit are used for network ID and 8 bit are used for host ID. So this 4 bit 221.21.23, these bits are not going to change. You need to change the only last bit, because to increase the subnet you are going to take the bits from host ID part, not the network ID part. Remember that. And we will, when we see the supernetting, I will tell you that we need to take bit from network ID part there, but here we need to take the bit from host ID part. And I want it to divide into 4 parts. So how many bits are required? How many bits are required to distinguish each subnetwork? With 2 bit you can do it. Okay, so I am marking them as special, and now remaining 1, 2, 3, 4, 5, 6. So these are the remaining. So try it yourself and tell me the network ID and the direct broadcasting address. Write it down. Okay, and I am doing here. So for this network, this is subnet 1, this is subnet 2, this is subnet 3, this is subnet 4. So for subnet S1 I am assigning 0, 0. Okay, and for subnet S2 I am assigning 0, 1. And for subnet 3 I am assigning 1, 0, and subnet 4 this 1, 1. Okay, now to get the network ID for the first subnet 1 S1, 221.21.23, these all will be remain 0. These 6 will remain 0, and what will you get? 0. You will get 0. So this will be the network ID of S1. And if I ask you the directed broadcasting address of S1, direct broadcasting address of S1, so in all these places you will write 1. So how many these are? These are 6. So if you write all places 1, so how to calculate this? Suppose there are this 6 1, 2, 3, 4, 5, 6. How will you calculate it? There is a processor, but you either use it, or either what you did that you just assume this is the 7. So 2 power 7 minus 1 will be this. 2 power 7 is what? Actually this will be 2 power 6. Why? Because it is starting from 0, 1, 2, 3, 4, 5, 6. So this will be 2 ki power 6 minus 1. 2 ki power 6 is 64 minus 1, it will 63. So these all ones are 63. So you will get 221.21.23.63. So this is for the S1. Can you tell me for the S2? For S2, if I ask you network ID S2, then it will be 221.21.23.64. I am writing here 21.21. This will be 127. It is easy. Try to verify it. I have done for S1. If you do for S2, how you do it? In this, for this 6 bits you write it all 0, and here we have 1, so it will become 64. Okay, it will become 64. Okay, see this 1, 2, 3, 4, 5, 6, 8. 1, 2, 3, 4, 5, 6, 7, 8. If I write it 1 here, that means it is 128. If I write it 1 here, then it is 64. If you add both of them, it will become 92. If I write it 1 here, it means 32. It is binary. It is the way you convert a binary number into decimal. Okay, that is, I am expecting that you already know. Okay, so for S3 try to find it and S4 try to find it. It is easy. S3 221.21.23.128. This will be the network ID, and when directory broadcasting address will be 221.21.23. We have to get all ones. Okay, so it will be 191. Try it and you will get it. So for S4 try it yourself. Okay, it's easy. So we have seen the subnetting, and there is one important thing is subnet marks. So what the subnet marks does, I will tell you. Suppose you have done the subnetting. So this was earlier, it was a one network, and now you have divided into 4 network, and this is the router. Okay, this is the router. It is connected to the outside router also. Okay, now when a packet comes for a particular subnet, this router has to decide to which subnet we need to send it. So how it is going to do that? It is going to do that using subnet marks, and how it will use it, I will tell you. Before we will learn what is subnet mark. So subnet marks is also 32-bit number. 32-bit number. Okay. In ones we have network ID plus subnet ID. So in subnet mark we are going to write one for all the network ID plus subnet ID. Okay. For example, here this, if you do the subnet ID and network ID, this is the network ID, this is the subnet bit we used it, so total it will become this. So for all of this we are going to mark as 1, and for the remaining host ID we are going to mark it as zeros, and we will get a subnet. So if you, for the previous one example, what is the subnet? If you, for the first octet you will write all ones because it is the network ID and we are not going to change it. So 255, 255, 255. For all of these you will get 255, and we have used 2 more bits from host ID. This is 4, 5, 6, 7, 8. So these 2 will be count as 192 if you change it into decimal. So we will get 192. So this is the subnet marks of previous network. Okay, and now suppose this IP address come to that network. What it is going to do? It is going to do bitwise ending. What it is going to do? Bitwise ending. And whatever it got as a result, that will be the subnet ID of one of these network. Okay, so let's do it. So suppose this is all ones, 1 1 1 1 1 1 1 1, and you represent 128. It is actually what we are doing, 121. Okay, now if you do 121, you write it into the binary and do the ending, you will get it 121, 221 only, because here is all ones, and 1 1 will end it. Try to end this, you will get 1 1 0, you will get 0, and 0 1 you also you get 0, and 0 0 you get 0. So you need to do the ending and you will get 221. So here we will going to get 221. Here also all 1 we are going to get 221. Here also all ones are there, we are going to get 23, and here it was 76. So first you need to write the 76 in binary. So I am writing it, last 8 digit, this, and this. So 4 5 6. So this is what? 76. How I do it? I know that this is 128, this will be 164, and this is going to be 8. So I just do it. But it is 76, not, I did it for 72. 64 plus 8, 72, and we need to get 1 4. So make this as 1 also. So this is, and we have 1 here, 1 1 0 0 0 0 0 0. Now do the ending. What will you get? 0 0 0 0 0 0. This is will be 1 0. And what is this? 64. So you will get dot 64, and to whose subnet it is the ID, we will see the previous. And if you see, this is for subnet 1, this is for subnet 2. So this is the network ID of subnet 2. So this packet will be delivered to this subnet. Okay, this subnet, because this will be, actually I am starting here with zeros and I am starting here with 1, so it's okay. So you understand how subnet mark is going to decide to which subnet we need to transmit a packet. Okay. Now how router is going to do that? How router is going to do that? I know that it is going to do some ending, but how it is going to do it? So it will going to make a routing table. In routing table we will be having network ID, subnet marks, and to which interface. This is the interface. Suppose this is A, B and C, D. This is the interface. To which interface we need to send it. If a packet does not belong to any subnet, then what it is going to do? It is going to pass it to default router, to where it is come. It is sending back. Okay. Here, it will send it back. So how it is going to use the routing table? So this is the subnet marks, and you will be getting, suppose this is one, okay, you will be getting this address. And now what is going to do, all these here is one, okay, because I already told you that class D is for mailing and we use for class C, okay, all of this is one. So now what we are going to do, this is the network, we are going to take the ending of this and see whether we are getting the same network ID. If we get the same network ID or subnet ID, then we will pass it to the same interface. Okay, we will try for this one. We will go serially wise. So we will try for this one, then this one, then this one, then this one. Okay, and even it is going to match with, suppose this one, it is matched earlier also. We are going to do it because it may happen that it will match with 23 ID. So and we are going to transmit to that one who's having longest subnet marks, more number of ones. Okay, so remember this and figure it out where we need to send it this packet. Okay, this I will give you a task. So that is how router are going to determine it. They are going to bitwise ending, and they will check whether we get the network ID of that subnet or not, and accordingly they will send it. So we have learned about subnetting. Or subnet marks is very important. Do some practice and you will get it. Now we will be seeing the classless inter-domain routing. So in classless IP addressing, what is happen? Suppose you already know the classful IP addressing. You know that how many IP address are there in one network. If to which class it belong, it depend upon that. Now I give you a problem. Suppose I wanted for my company, I wanted 500 IP addresses. Tell me to which class network I should buy. It is class C. If I brought class C, then I can get 2 power 8 minus 2, that will be 2 power 254. Okay, if you just remove this minus 2 now here, so we get only 254. So now I should get a by 2 power class B. If I buy class B, it will be 2 to power 16, that is 64K. And that is huge. That is not my requirement. My requirement is only 500 MB. That is huge number. If you multiply, it is about 64,000 IP addresses. That is not my requirement. My requirement is only 500 IP addresses. So this internet assigned number authority, these people thought that what we are using classful IP addressing is not that much efficient. We should use something else. Because if someone requirement is this 500 and it is buying the class B network, then it is wasting lot of that can be used. So that is why what these people thought that think it as a cake, and if whatever your requirement, try to cut it. So my requirement is 500, I will cutting 512 IP addressing from here, because 500 is 2 to the power 9. So it is in the power of 2, that is why I write it like this. So I will cut this piece of cake and I will use it. So it is like that. Suppose your requirement is much big, so you can cut a bigger piece of cake. In this way we will waste little, very little will be waste. So that is the use of this classless inter-domain routing. So cut the cake according to yourself. Now there are some rules to get the block from CIDR. So first rule is that all the IP address should be continuous. All IP address should be continuous. And second thing, that when you are cutting the piece of a cake, it should be in power of 2, because it will make it easy to get the network ID and host ID. Here we are going to use the term block ID. Instead of network ID, we are going to use the term block ID. And the third rule is that first IP address in the block should be evenly divisible by size of the block. So I tell you what it is. Okay, I will tell you the third option with an example, then you will understand it what it means. So you understand that you can cut it any requirement, but it should be always in power of 2. Whatever your requirement, cut it, but it should be in your power of 2. Now how we represent it? Suppose this is the IP address. Here it is dotted decimal representation. So A, B, C, D are there, and block ID is represented by this N. After slash we write the N, and it is saying the block ID. So N bit are used for block ID. N bit are used for block ID. Okay, and how many bits are used for host ID? 32 minus N. So in this way you will get for the bit used for host ID. So total number of IP address present in a block is 2 power 32 minus N. Suppose this is the network ID, and this only this tell about the number of IP address we can get. So this is what? This is N. So after you do the 32 minus N, you will get it. So see this example, and we need to identify whether it is following all the rule of CIDR representation. So this is the first one, this second, and so on till 127. And first check whether they are continuous or not. So yes, they are continuous. If you write into the decimal, you will get it, but I am showing you only the last octet, this last one. So it is 0, 1, 0, 0, 0, 0, 0, 0. And for 65 it will be 0, 1, 0, 0, 0, 0, 0, 1. And so on for 66, it is continuous. It is continuous. And what it will be in the end? 0, 1, 1, 1, 1, 1, 1. All ones are there. Okay. So this will be that. So it is continuous. We understand it. Whether they are in power of 2 or not. How many these are there? These are 64. And it is 2 to the power 6. Okay. So second rule also follow. What does the third rule say here? The first IP address in the block should be evenly divisible by size of the block. So what it is representing? What it is want to saying? So it is saying that the first IP address, this is this one here. So I am writing 120.20.32. It should be divisible by size of the block. So size of the block is 64. So when you divide it, actually how 1, 2, 3, 4, 5, 6. So in binary division in power of 2 is very easy. How I tell you that? Suppose this is what we want to divide it, and this is what. So if you wanted to divide it with 2, then this will be your quotient and this will be your remainder. If you wanted to divide it with 2 to the power 2, that is 4, then this portion will be your quotient and this portion will be your remainder. If you divided it by 2 to the power 8, this will be your quotient and this will be your remainder. So that much easy is. Now we wanted to divide it with 2 to the power 6. So 1, 2, 3, 4, 5, 6. So this will be your remainder and this will be your quotient if you divide it with 2 to the power 6. So yes, it is evenly divisible. Evenly divisible means you get remainder as 0. So yes, we are getting 0. So all three these rules are followed. Now we will see supernetting and aggregation. Supernetting, and sometimes this is also known as this aggregation. Okay. So what is supernetting? We understood that what is subnetting. We are dividing into subnetwork. What is supernetting? Supernetting means we are, instead of dividing, we are with the small network, we are making a big network. Sometimes we do it. Because why we do it? Because at a router, what happens that there will be lot of entry, we have lot of small network, and to process a packet it takes lot of time. So instead of doing that, we club it, make a big network. Okay. So what are the rules for supernetting? So first one is continuous network. They should be continuous network. Second is same size in power of 2, and the first IP address should be divisible by the size of super network. So these three rules are almost similar to that one we have learnt in CIDR representation. So we will see this example and try to understand it. So how many bits written here? 24. That means how many bits are used for block ID? 24 bit. So these 2.8, 10 dot, this is used for network ID, and the remaining 8 are used for here. Okay, this is the remaining 8. Now what is the question is that can we make the supernetting here? So if you show that all should have the same size also, and it should be in power of 2, and they should be continuous. So if you see this 24, okay, how many got? All this can be 1, and when you see the next one will be the 1 here, and this is all 0. So yes, this is one network, 0 0 0 0 0 0 0 1, and so until all 1 here. Okay, and after that we get this is n1 and this is n2. So seems like continuation. There is a continuation. So if you see that all of these are continuous, first point is satisfied. All have the same size. What is the size? 2 की power 8 is their size, because 24 bit are used for network ID and 8 bit are remaining, that is used for host ID. So their size is 2 की power 8. So all of them have same size. And how will you represent, if you club them, then how much you will going to take the bit from? You are going to take the bit from network ID. In subnetting it is opposite. Okay, we are going to take the bit from host ID. Here we are going to take the bit from network ID. I asked you what will be the size of total super network. It will be 2 की power 8 plus 2 की power 8 plus 2 की power 8 plus 2 की power 8. That is, if you take this and if you write it like 2 की power 2, it is 2 की power 10. So 2 की power 10 will be the size. So if its size is 2 की power 10, how many bit are going to used for network block ID? 22. Why 22? Because 32 minus 10 will be 22. 0 0, write it like 22. So this will be your block ID. You can say it is a block ID. You can use any network, you can also use it to represent this super netting. You can use like this, 2 की power 8, this 1.23, like this also you can use anything, but this will identify already the block ID, so there will be no problem. And we will understand that to get the block ID, all 0 should be there. So we will these two representation representing the same network. Okay, so now the third rule was that it should be evenly divisible. So you see that here are 16 zeros are there, and here it should be divisible by 2 की power 10. If you divide it, 10 zeros are there. So yes, it is, third rule is also satisfying. So now we see this question. If you understand this question, you will mostly understand whatever I have told you in this topic. So we are given the routing table of a router, and these are the network, and this is, it has various names. Sometimes it is called subnet marks, supernet marks, or net marks. So it is here given as net marks, and these are the interface to which we need to send it. Now what they are doing, they are giving some IP addresses, and they want you to tell me at which interface it is going to be there. Okay, so if you see this one, what we need to do it, I write it this here, 128.96.171.0. this is what it is. And now I need to do this ending with this and see whether whatever ID I got, it is similar to that or not. Okay, and if it is not, then we need to go to this. Even if it is same, then also we need to go for this, because we need to take the longest subnet mask. This is, I don't think this is the same question, but I will show you where a longest subnet mask will come. So don't worry about it. So try to do the ending with this. If you do the ending with this, I am not writing into binary because it will take lot of time, but I will write whatever needed to be write. So here I need to write into binary to see what it is. So how to represent 254? 1 2 3 4 5 6 7, this will be the 254. And how to do 171? So to do 171, what I am going to do, this will be 128, and with this will be 64. If I write it 1 here, it will become 192. So don't write 0. If I write it 1 here, it will be 32. So 128 plus 32, 160. Then I got till 160, and now we write to get 11. So 11 I can get from these 4 bit like this. So this will be 171. If you do the bitwise ending, you will get this. here you get all 0, so it will be 1 0 1 0 1 0 1 0. So you will get this, and it is 170. So you will get 170.0. Okay, and to which network it is belonging? The first one. Okay, here it is belonging. So okay, and it is also longest because 154 and we get 152, so it is obviously the longest. So this one will be going to interface 0. Okay, so this is, I am matching with like this. Now do it for this one here, 128. So if you do it for this one, okay, it is 128 dot, what it is, 96.167 167.151. So now do the bitwise ending with first one, then go for another one. Okay, so if you do it with this 254 255.255, this is 254.0. so try to do the bitwise ending. If you do the bitwise ending, it will be 128.96. Now we need to do it like this again. So I am doing here 11111110. If you write it 167, it will, I am directly writing because I have already written here 0 and last 3 1 are there. Okay, now do it. It will be 0. Here it will 1 1 and 0 0 1 0 1. So it is 1 0 1 0 0 1 1 0. So what we get? Actually we are removing only this one here. So and it is 167. So it is, we are getting 166.0. So we are getting 166. See, it is belonging to this, not this. So it is R1 is matching. R1 is matching. So it will be, it is R1. So actually it is 167. Let me check it once. 167. So yes, 166. It is matching with this. So like this, try for other example actually and see which is we getting. Here I think I have something written wrong. Here should also be R1. So I told you how to do it. You will also understand it. So complete this question and see what you are getting for these two also. And this is the written, I have written the answer here. So I think this is R1. Okay, this is R1. It may be R1. Okay, so do that question. That's all for today. I have told you about supernetting, subnetting and subnet marks. And in GATE examination, question really come from this topic. So do some practice. It requires some practice. After you understanding concept, do some practice. And to understand the concept, understanding the concept is very important. So make sure you understand the concept very well. If you are not feeling that you have understood the concept very well, read books. Because standard books are very good source to understand the concept. Okay, thank you.